Euclid's 29th proposition says that if we have two parallel lines, then angle BGE is equal to angle DHG. That is, corresponding angles are equal. External angle is equal to the internal opposite angle on the same side. Secondly, it says that the internal angles on the same side sum up to 180 degree and alternate angles are equal. So basically it is the converse of the previous proposition. Okay, let's see how we can prove that. Again, we will use proof by contradiction. We will assume that AGH is not equal to DHG. That means these two angles, alternate angles, are not equal. Now, if they are not equal, they have to be either one of them has to be greater than the other. So let us say AGH is greater than DHG. Okay, so that is an inequality. To the inequality, we will add angle GHGB, this angle, to both the sides of the inequality. So what do we end up with? We end up with AGH plus HGB is greater than DHG plus HGB. Now we know AGH plus HGB, they are on the same line, adjacent angles. So they sum up to 180 degree. So we can say now that two right angles is greater than angle DHG plus HGB, or if we reverse it, we will end up with angle DHG plus angle HGB is less than two right angles. Now we have already seen in the previous propositions that if they don't add up to two right angles, that is 180 degree, then these two lines are not parallel. AB is not parallel to CD. But we are given that these two lines are parallel. That means our assumption was wrong, and we can say that angle AGH is equal to angle DHG. Of course, to really complete the proof, we have to also look at the other case where AGH is less than DHG. Since we have only looked at the case of greater than. Okay, but the logic follows the same thing. So we have proved that these two angles are equal if these two lines are parallel. Now the second part, we have to prove that angle BGE is equal to DHG. Angle BGE, that is corresponding angles. Angle BGE is equal to AGH, vertically opposite angles. AGH is equal to DHG. Just now we proved this. Okay, since these two are equal, we can do the substitution. So we end up with angle BGE is equal to DHG. Let's look at the third part. It says that the sum of these two internal angles on the same side sum up to two right angles. AGH is equal to BGE, right? AGH is equal to BGE. Why? Because they are vertically opposite angles. Now to this equality, we add to both the sides angle HGB. The equality becomes angle AGH plus HGB is equal to BGE plus HGB. Now, we know angle BGE plus HGB, they are on the same straight lines, adjacent angles. So they sum up to 180 degree. But we also know that AGH is equal to DHG. So if we incorporate that, we end up with angle BGE plus HGB is equal to 2 right angles, and then we substitute that BGE with the corresponding angle because they are both equal. So DHG plus HGB is equal to 2 right angles, which is what we had to prove. So that is proposition 29. If the two lines are parallel, then alternate angles are equal, corresponding angles are equal, and the sum of these two internal angles on the same side is 180 degree. Again, let me remind you that there is a PDF, a link to a PDF file which describes all the 48 propositions of Euclid's book 1 of elements. That's it for now. Bye.